Welcome to the data science program. And in the previous lectures, we were just a second. Good evening, everyone, and welcome to the data science program. In the previous session, we were discussing about the fundamentals of the machine learning in terms of the first algorithm that is called as the linear regression. So we have discussed about the theory part, the mathematics behind it, and what are the supportive uh, topics that we are supposed to consider whenever we are going to discuss about or whenever we are going to implement the linear regression. So to start with the coding part of that, today we will be looking at what are the various coding libraries we are supposed to know and what are the fundamentals in terms of the coding. Again, we are not directly jumping into solving the problem because that may not help everyone in understanding and everyone in say implementing it efficiently. Okay, so because of that reason, we are not jumping into the solution of the problem which we had discussed or decided to solve uh, in the first session. We are not doing that. We will be starting with the coding part step by step so that we understand everything, and we'll try to solve another very simple problem in today's session, so that maybe the next session will be the actual session where we'll be implementing that particular one problem which we had discussed. Okay, which includes every aspect of the first phase or the initial step of the machine learning. Okay, I hope that is clear with everyone. All right, so let's do something. uh, I expect everybody to code along with me. You can use the Colab or the Jupyter notebook. All right. So please tell me, Niranjan. No, no, no. Just starting. Just starting. Okay. We are starting with the coding. That's all. All right. So you can see nothing has been written so far. We are just starting. All right. So import numpy as np. So this will be my first step. Right. What I do, I want to create a simple data set. Yes, Gaurav. No problem. Yeah. Please go ahead. Files in the sense data set. Yeah, yeah. Whenever we are using something, I'll share it. Okay, as of now, no need to use any of the data set. First step is learning something very basic, so I'm not using any data set. I'll create a data set. Okay, so just see here. Okay. So I hope you understand what I'm trying to do now. So np.arrange. Okay, sorry, it's not arr, my mistake. Arrange 1 comma 25 dot, I'll do a reshaping. I'll say give me the shape 12 cross 2. All right. So those who don't know what it is, just look at this. This is what is the result. A range is a range starting from 1 to 24. There are 24 elements. I'm asking you to reshape. Reshape me 12 rows, 2 columns. Okay. Fine. We get this. Let's say this is our x-axis. Okay. Sorry. This is the data set x. Then corresponding to data set, I should have some y, right? So y is equal to, this is my, let us say this is the label, right? So y is equal to numpy np dot, let's create an array. So let's put some, I'll put some random values, that's all. Okay, 0, comma 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So you see, for 12 different values, 1, 2, 3, 4, 5, 6, like that. Each whatever you see, each array is, right. Each row is one data point. 1 comma 2 is a point. 3 comma 4 is a point, and so on. We can see that there are so many data points available, and corresponding to that, I create a, say, classes, two classes. 0 is one class, 1 is the other class. Let's say 0. Okay, so let's create this. Let me try to print that for you. Okay, so you can see that this is what is my data set, let's say. Right. The very first thing that we need to understand here is the concept of splitting this data set into training data and the testing data. So what is the other name I told for training data? Anybody? You can put the answer in the chat. Right? What is the other name? I didn't use the training data. I called it by some other name. Okay. So you think about that, type that answer, you refer the material we have given. Meanwhile, I'll try to type my next part of the code. Okay. So sklearn dot sklearn dot yeah, so we have answer from Ruchi, right? We actually call it as a development set. Among the development set, you can go for cross validation, k-fold cross validation. You divide your development data set into k different pieces, remove one piece from that, the k minus one pieces will be used as a testing, sorry, the training, and this one piece which you separated will be a validation, but then it will be repeated. Okay, so yes, absolutely fine, that's correct. Now, in order to split this in the required format, you don't have to write a code. Okay, so you can use there is a built-in function that is available, but it is present inside a particular library that is called as a scikit-learn, sklearn. All right, so let me search for sklearn so that you can see the help scikit-learn. Yeah, you can go for a scikit-learn. Simply search for scikit-learn, sklearn. It's fine. So it will directly take you to this. Okay, let me paste that directly. You can use this link so that you can visit the scikit-learn related documentation. It actually is a very huge documentation, right? And you have various options. Anyway, that the discussion of scikit-learn is not a part of our whole course, so I'm not going to go there in talk about any part of this sklearn. All right, so directly we'll use what is required and we'll go ahead. But if you require to identify, or if you want to go ahead and see what are the various functions, what are the various modules present inside this particular uh, sklearn, you are free to use that particular link. Okay, fine. So in sklearn, right, I have to import the particular function which I want to use. Okay, so that is present inside the what is called as model selection. Yeah, you can see it actually suggests sklearn model selection. From this I want to import, I will import what is required, because everything if you bring in, your computer's memory will be filled with all the data that comes along with the complete library. So don't do that. Most of the time from sklearn model selection we'll be using only one function. Okay, that is called as the train test split. Okay, just bring that, only one thing to your computer. All right, so I bring that. Now from my x and y, so I have a x which are actually the table. X actually can have multiple columns as well, but right now you see I'm just using two columns. I created this data, so only two columns are there. Y is actually a label saying that each data point is class 1 or class 0. So this is actually a regression problem or a classification problem. Just put your answers on the in the chat, whether this particular problem we have created here, right, x and y, if I want a machine to solve this, it becomes a regression problem or it becomes a classification problem. It's my question. Yes, we have an answer from Ruchi saying that it is a classification problem, because we are not asking the machine to generate every possible real number, right? It's actually going to tell that whether it is 1 or 0. Means one class, 0 means other class. So discrete values it is generating means it is classification problem. Yes, that's perfect. All right, so we imported the particular train test split. As the name suggests, this will split your data set into training data and the testing data. All right. Now the question is from where you get this. Remember that this is very important. Every time you are going to import it from here itself. Okay. So from sklearn dot model selection, import this particular function and how to use it. So to use it, you know how to use a help. Go to help and find it out. So write the train test split. Then you can write a question mark. It should give you help. But right, I'm not going to do that. Right, just do that, and I'll just tell you the output. Exit train. Yeah, please go ahead, Devendra. Okay. What not found? Okay, then you don't have sklearn installed in it. It's a default. By default, sklearn will be present in every system. So you can go to the Anaconda right main page and you can select that you want to install SK scikit-learn. It's actually written as a SK. You use the link I provided. Okay, when you go there, that there will be a help saying that how to install that. Okay, go to the install part. You can see that if you are using right Anaconda, right, you are supposed to use this particular command. Okay, so you can see that. Yeah, pip is also there. You can even use the pip if you want, right? So just see here, it will help you out in every case, right? Which particular OS you are using, and right, how do you install? Do you want to install using pip? Do you want to use a conda, etc. All right. So simply pip install scikit-learn is going to install directly. All right. Okay, so we were using the train test split. I'm coming back to that. So the outputs, there will be four outputs for this function: x train, x test. You can define anything over here. Let me define this in the small itself. X test, y train, and it is also going to generate what is called as a y test. So X are your input data, Y is the class. Okay. So for the test data, you split your data into some part. For each and every point, what are the Y values will be present in the Y train. Similarly, you split the remaining half, maybe remaining part into the X test. That will be a testing data, right? Corresponding to those data, what will be the expected Y values? What's the right answer, right? Will be present in the Y test. Okay, so this is equal to, simply call the function the train test split. You just have to tell this is my X, this is my Y, and what is the size, because I have to tell that okay, I want 80-20, I want 75-25, right? So to do that, go for the test size. Test size is equal to, you will write a fraction. If I want 80-20, so the 20 is what I'm writing here in the form of what do you call, I'll try to write that in the form of the ratio. All right, so you can write a ratio here, or even if you don't write a ratio, you can write the exact number here. Like if you write any value between 0 to 1, it will be considered as the ratio. But if you give it a number here, for example 4, right, test data will be 4, remaining will be the training data. In this case, you can see there are how many points? 12 points. So out of the 12 points, 4 of them can be used for the test. Let me try to show you the number itself, because in this case the data set is very small. When the data set is huge, what we can do, I'll show you later. All right, so this is the text test data and the train data. Let's look at them. So X train is this. All right, so you can see randomly it has been chosen. Then X, okay, corresponding to X train, I should have a Y train. So just see that. So corresponding to 3, 4, whatever was there in this array, right? Whatever you had in this array has been copied to this. So this is correspond to 3. This is corresponding to 11, 17, 18. Next one 13, 14, 1, 2, and so on. Okay. So it actually has split up in the same way. Yes, Ruchi, please go ahead. No, it is not a test, right? I'm showing the train. I'll show you the test now. So X, right? So let's see here. X test. See, only 4. Okay, then Y test is this. So corresponding to those numbers, 15, 16 in my original data, that belongs to class 1. 21, 22 belongs to class 1. 23, 24 belongs to class 1. 7, 8 belongs to class 8. So it has been splitting up your data according to the specification that you mentioned. So this is one very important what you call as an algorithm, right? Actually, internally something runs on the background, and that actually splits this in the way you have you are mentioning. Okay. Yeah. Can you see? Oh, okay. All right. So that's one very fundamental what you call as the step, right? So we need this, and now in the next step, what we are trying to do here is we'll take up a data set, very simple data set. I'm going to share you that. All right. So everybody, just look at your chats box, and you will obtain a particular data set. Let me check. Let me check where is it. Okay. Yeah, it has been added. It's called as auto MPG. Just give 1 minute of time. Within that, it will come. Okay. Auto underscore MPG dot CSV. It's a CSV file. Right? Everybody open that. Don't open in the Jupyter, or don't. I'm not asking you to open in any of the editing tools like this. Don't bring it into the computer's memory. Simply open it using say Excel. Okay. So just open that, and we'll discuss about it. So open using Excel. It's there in the chat. Okay. Anybody, if you can share that file in your WhatsApp group, that will be beneficiary. Please do that. Anyone who has received the file, because all right. Thank you. Yeah. So those who have not received, you will receive it in your WhatsApp group. Okay. So please check that and download it to your computer and open it using Excel. You will be having Microsoft Excel, right? So simply open that over there and see what are the various columns that are that you can see over there. So the maybe I'll tell you some of the names here. For those who open, you can see that. Okay, the one information is about MPG. MPG is the miles per gallon, right? So that data set is not Indian data, it's a vehicular data for some other country. So where they measure miles and gallons. Okay, so miles per gallons is what you can see there. And you have the cylinders, number of cylinders in a vehicle. Then you can see the displacement, cc, cubic, right? That value, horsepower of a vehicle, weight. You will see the acceleration. You will see the model, which year is it has been manufactured, maybe the origin, which country it is. Then you will also see the name of that particular vehicle. So you have a data set like this. So I think you have around 400. It's not a very big data set. Just to get hands on with our fundamental concept, we are going to use this data set. Okay. All right. So it has been shared in the WhatsApp group. Everybody, please check. Fine. So the next part is that how many instances you have, how many rows you have. If you check that, there will be around 400, something around 400, 390, 395. Okay. Then so many columns are there. Now the question here is that use that complete data set and predict for any row given. You have to predict what is your y value. Y value is a mpg, the miles per gallon. Fuel consumption is the question. For any value we give, right, out of that table, right, any row I give except the mpg, you should design your machine, you should teach the machine how to predict the miles per gallon or the fuel consumption. Okay, that's our fundamental question here. I hope that is clear. right? So after opening and visualizing that, right, if you have understood that, close that. We don't want that Excel file anymore. Close it. We don't want. Let us bring the data set into our computer's memory using, right, Jupyter or Colab or whatever you are using. Okay, so let me call it as auto is equal to, yeah, I think I don't have pandas with us, so import pandas as PD. All right, so panda comes into picture now. So is equal to PD dot uh, not data frame. I have to read the data, correct? So what is the command? Anybody knows that? Have you seen read CSV? Okay, for reading CSV files, this is a command. You just have to tell what is the name. Auto mpg dot CSV. Write it completely inside single quotes or double quotes, doesn't matter. This is how it's going to work. Then you see, I want to see the few rows of that. So auto is the uh, actually this is a data frame. Directly it became a data frame now. All right. So you don't have to convert this into data frame again. pd.read CSV converts your CSV file into the data frame. Okay. So now auto is a data frame dot head. So you can see, yes, this is how my data looks like. So all the columns I mentioned, you can see here. MPG, cylinders, displacement, horsepower, dot, 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 etc. up to the car name at the end. All right. Then the next question, I'll show something else. Again, I want you to recall this because this repeats again and again. I may not do this part, whatever I'm going to do now, next few lines of code. I will not be able to, I will not do that in any other machine learning algorithms. Okay. But initially, just to make you to recall, okay, these are the various options we have in pandas. Yes, I'm trying to do this. Okay. I'll try to what you are going to type if you want to see only the number of columns. Write the name of the data frame dot columns. Yeah, so you do this, you see only the columns. Okay, then how do you summarize, right? How do you do a statistical summary? How do you bring the statistical summary of my data set on screen? If you remember, type that. Yes, describe. So there is a function, right, which is called as describe. Statistically, it will show what are the details it can give to you. Okay, so again, remember, describe eliminates those columns containing non-numerical data. Only the numerical data, if you have, right, it will show that. Others, it will not show. Okay, so just check that once. So only out of the main columns, only these columns are present because others are non-numeric. Maybe you have text over there or something else. Okay. Anyway, let's not waste time. Let me go further. How do you find out the information related to this? What data type it is? Is it null? Is it not null? And how many entries are there? Can you try to write that? Auto dot. There is what is called as the information info. Right. Remember this. This is also very helpful. So I'll show it to you only this time. Okay. So it also shows how much memory that file has taken. Right. Okay. Absolutely fine. Then, yeah, sorry. Not all. I just now it has been shared in your WhatsApp group. Correct? Can you find out? Auto. Same. Okay. Same thing. Same. Okay. Download that to your computer and load it. Sure. Right. So we'll move one step ahead. Can anybody suggest how many uh, not a number entries are there? Missing values, not a number, anything, you whatever you call. How do you check that? If you give me a command which actually tells each class, like okay, each column, mpg, these many not a numbers are there. Cylinders, these many not a numbers are there, right? How to get that? Is na is a function. I'm giving you a hint. So use that. ISNA is not a number, or right, is a missing number. You can use that command ISNA. But how to use ISNA, right? You can see on the screen what you are supposed to use, right? Use this properly so that I can see column name and the number of missing entries over there. Column name is MPG. If you don't have 0, if you have 10, 10. Next, cylinders, there are 20 missing numbers. Horsepower, there are 30 missing numbers. Like that. I want to visualize that, right? If you try by yourself. I'll give say 30 seconds of time, and if you get an answer, put your answer in the chat so that we can discuss. Auto dot is NA. Okay, then dot sum. Yes, so that's correct answer. Okay, auto dot is NA. So this tells are there yes or no. Then get a sum of them. Column wise, you get a sum. So this is what I expected. In this case, the data set is not going to have any missing numbers, any missing values. All right. Okay. Now, anyway, so since there is no missing values and you already have a numerical data completely filled with numerical data, I can simply neglect that particular column containing the name of my vehicle. Name of the vehicle is irrelevant to calculate the what you call as the MPG, the mileage of a vehicle. So anyway, you can remove that. That's fine. So I don't have to do any other processing as of now, right? So let's stick to that, because as I told, this is the level 1 very simple problem statement. All right, so we study every aspect of linear what you call so every concept related to the linear regression we'll be studying here. Then we'll apply this to the next level problem, which is our major problem, and while doing that you will see the practical issues. Okay, so as of now we kept this as simple as possible. All right, so I have next question, so try to answer that. I want you to create a what is called as pair plot. So already this has been discussed in the data visualization using what you call uh, Seaborn, Matplotlib, etc. Right? So want you to recall that. I want to look at a pair plot to check, right, how these various features are correlated. So correlation between the various features is what I want to see. Okay, so definitely I need I'll anyway I asked the question, so if you want to see that name, I'll just write again. This is my question, right? But before that, I have not imported any of the visualization module, so I'll bring them. Okay, import matplotlib dot pyplot as plt, then import. Okay, I want you to plot that. So anybody, it's a single line command. You don't have to write multiple lines, nothing. Very straightforward, very simple. That's why I asked the question so that you can enter, you can try that and give me an answer. Simply copy that particular command on, you can share it on our chat box. Okay, anybody? I'll give 30 more seconds. Yeah, so we have an answer. Pair plot of auto, right? Use whatever alias name you have given. So I think Gaurav has given SB, so absolutely fine. So let's do that. SNS dot, it's called as a pair plot auto. Oh, my mistake. I think I have not. Yeah, it's there, right? It will come. Okay, this looks like this. If you want to make it more beautiful, I have a suggestion. Okay, just before this is fine for us analysis purpose, but people want to have catchy colors or make it more interesting so that somebody gets an interest in seeing this. This everything looks like a same color, so people might think that what is the result, right? So I suggest you to go and use the style. Okay, so just think about this. I'll just show you one option, plt dot style dot use, right? You need to remember some names here. That's what that's necessary. One of my favorite is ggplot, right? Brings basic colors into picture, not eye-catching, or not too dark colors. So some light colors will come into picture. So that's why I remember this one most of the times. Okay, still I don't see plt.style. Let me try to run this again. It's working right on your system. All right, fine, fine. Yeah. Again, today I'm not running on a GPU. I'm on a CPU, so my system will be running pretty much slow. But anyway, so just I have shown what command to use, right? So maybe if your system is fast enough, you will get a quicker result. Okay, so let's not waste time here. When it comes, I'll show you again. Okay, so I have a next question coming up. Can you plot a heat map? I want you to I want you to plot a heat map. I'll just type what I expect. I want a heat map. Why I want a heat map? Because I want to visualize the correlation between the various features. Okay, again, automatically it will consider only the numerical values, and I want you to plot a heat map and visualize in terms of numbers, because this the pair plot which you have got so far is going to show you the complete details in the form of dots or the bar graph, correct? So yes, many of the detail, many information hidden in your data set will be able to see that, okay, in that. But if I want to see numbers, right, I prefer using what is called as a heat map. So that is the next step. Again, we are still in the data munging itself. We are still doing the data processing and trying to understand what is present in this particular data, right? We are trying to get more information about it. So I want you to, right, go with the heat map. All right, so I'll directly start with the coding, because it expects at least 2 or 3 lines of code. But the main line of the code, if you have, you can type that. So I'll use plt dot. I'll bring a figure. Okay, so the figure is used to create a figure, the space where you can print or where you can bring your particular plot. So in this case, we are looking for a heat map, but I have to tell machine that what is the size of the the space that I'm creating for my plot. Okay, so let's try to recall. I'm trying to make you to recall these. So you can say 10 comma say 8, right? So any number you enter, according to that it will allocate the space. Then you have to use the cborn itself, sns dot heat map, right? You have to tell which is your data set, auto dot c. In order to get a heat map, you should have the correlation between every column. So you simply call CORR. All right, then you can have various other details. I will show you some of the important ones, right? You can, do you need annotations, which row, which column it is you want that name to be printed, then say, right? Most of the time this is very helpful, so I use it. Then you can say, if you are separating them with the lines, right? What is the line width? So you can say line widths equal to I think width or widths, let's see, 0.5, let's say. Then you can have the center, where you want the whole center to be, right? At 0, slightly shifted to right, left, etc. Make a variations in this and you will be able to understand that. Okay, then I'll say plt dot show, right? So dot figure. It's splitting the previous graph now. Just hold on. All right. Yeah. It's coming here, right? Okay. So you can see this is coming for me. It is coming. This is the previous graph. All right. This is the fair plot. Okay. So and you can see here, right? This is the heat map, right? So you can see on the rightmost side you have a it's a color bar. It tells you which color corresponds to what value. As you can see here, yeah, just hold on 1 second. As you can see on the rightmost side, if the color is tending to be more darker in terms of red and then becoming brighter on the red side, that actually is a positive number. So you have the value tending towards blue, that means it is a negative number, negatively correlated. One increases, other decreases is negative correlation. Okay. When the one of the parameter increases, other parameter also increasing, it is a positive correlation. Okay, yeah, just analyze. Meanwhile, I'll try to answer the question. Yes, please go ahead. The location of the program and the location of the file should be same folder. That's all. That's the only condition. Just check whether they are in the different. No. Program is also running from the same location. Documents only. Just check once. Just check once again. Just make sure that it's right. You have a folder. In that you have the program. You have the same folder and you should have the file whichever has been sent, that also should be over the same location. Okay, that's the only condition we have. If it is there, it has to run. What is the error that you get? You are in the sense these graphs, correct? Before these things you are getting auto describe, you are not getting anything. What is the error? That's what I asked. What's the error that you get when you type this line? No. That's not what I am able to guess. What is the problem? If it can tell, see, if there is a problem with the file, it will tell. Okay, it will tell below your command. So I'm expecting something like that. If you can tell something like that, I can help you out. Otherwise, as of now, I'm not understanding what is the issue. Okay, only condition is that it has to be in the same location. Only that. Then you should have all the required, what you call, like pandas, numpy, etc. Yeah, same location. Wherever you open the Jupyter notebook, if it is in the document, your file also should be in the document. If you are opening from the desktop, keep both the files in the desktop, your Jupyter notebook as well as the file which has been received, put it in the same location. That's all. Okay, change the location, put it into some other location and try to. Okay, because maybe in that location you may have some problem. Put it into a different location and try. Okay, so let's move ahead now. Fine. So we have we'll start with the, what you call as, the analysis part of this. So far we understood that some of the features are positively correlated, some of the features are negatively correlated. Whenever you see one, they are the same uh, parameters. Origin versus origin is one, because when origin increases, other origin is also increasing only, right? They're the same one. So there is a highly correlation. One means 100%. Okay, other values are there. Anyway, you know what is a correlation, etc. You can just analyze this. I'm not spending time over here. Let's move further. Right, I will go ahead and I'll check out, yeah, what are the unique values in the horsepower, right? So I know that there's a column called horsepower. I want to look at the unique values in that. So how do you do that? So dot, you can use dot, or I prefer initially I want you to use this itself. Go to the particular this is the name of the column, name of the series. All right, dot, then write unique. So you can see these are the unique numbers present in that particular column. In the sense, this is like a set. A value 130 is written means if you find another 130, that will not come only once. Okay, so these are the unique values. Okay, I can see there is a problem. Why I asked the question? Because of this itself. Now I want you to write a command so that this question mark gets removed from my data set. Okay, so there is a uh, particular value in the column which says there's a question mark, right? Horsepower has a question mark. So I want to remove this from my data set. What do you do? What is the command that you're going to write? I don't want to replace. My question is very clear. I want to remove. Okay. So question is just remove. Yes, what you told is right. I can replace that with many other options. But my question is, how do I remove? What is the command that you write? Multiple options are there. I'm going to give my version. Yes, let's discuss. If you have any other answer, please go ahead. Yeah. Okay. You say you want to drop. Yes. Can you write a command and check that? Can you use drop? Yeah, replace is one option, but right now my question is how to drop, how to remove. I don't want to remove it completely from this. Whenever I check the auto horsepower dot unique, I should not be able to see a question mark in that. So that if it is removed completely from the data set, when I look at the unique part once again, it will not come. That's my question. Okay. Drop NA will remove NAs only, not the question mark. Question mark is not a number, correct? It's not a missing number. Yes, yes, yes. Think over it. I'll try to write my version. Again, this is only my version. There are many answers possible. Okay. Hmm. Okay. Just try that. Whether will it work? It may work. Okay. So just try that. And after running that particular part of the code, you have to check this line number 24 once again. You run that once again so that this question mark should not be there. That's the only condition I have. Okay. Yeah. Maybe we got one answer. Others, please try. Auto of okay, let's assign this to auto itself. So auto equal to, right? Go to auto. Which particular column I should go? It's again present in the auto itself. Auto of horsepower. That's right. What is the condition? Condition is that it should that every value in that column which is not equal to question mark. Correct. So can I write not equal to, then I see the question mark is just like this. Okay. Will it happen? Will it do the job, or is it wrong? Let's check this. Auto horsepower dot unique. Let's check. You see, before 193 and 100, third line, we had a question mark. Now we don't have. Saying that it's not there. Okay. Anybody else who got similar answer by your own method? Yes, we are here to discuss now about that. Okay. So meanwhile, I have a next question coming up. That is, which is a command that you use to look at the various data types of each column? Because every column is of a different data type. It may look like everything is numbered, but you may have a you may have a 16-bit representation, sorry, 32-bit representation. You may have a floating point representation. You may have an object present over there. You see, various types are there. How do you check that? What is the command? Yes, anybody? So dot D types. Info also gives you that, right? I think. Okay. Yeah, you can see that. Okay, info is there. Want only D types, data types means this is the command. Okay, let's just check. All right. Now let's look at say. Okay, you see, this is what I find very difficult to handle because the horsepower is an object. Okay, but horsepower I want it as a say floating type, because let's just go back and check the particular column. There is a horsepower. Yeah, you can see that there is a horsepower written here. It looks like number to you, right? 130, 165, 150, 150. But when you look at the data type, you understand that this is not in the number format, it is in object format. So I need to convert that into numbers by using this. Is again, nobody will tell you that when somebody gives you a data and somebody is going to ask you a question. Okay, let's do this. So nobody is going to help you out in that. So you should do these kind of steps. You should analyze that. Okay, this is what I am supposed to do. Then you should be able to guess at least. Okay, I want to use a command like this so that I can, right? I can do this conversion. So how to do that? This is an option, auto. In auto, right, I have to consider I want the result to be present in the same column. It's a horsepower. Okay, but you see, this is equal to the same thing, auto horsepower. But what you want to do, what you want to change the data type from object to something else, correct? So for that, remember this, this is applicable for any type of data. So you just have to use as is type, as ey, yeah, as type, right? You have to tell what is your expected answer, irrespective of whatever it is. It may be a string, it may be character, it may be integer, it may be anything, any format, object, it may be anything. So what you want as output, you specify. I want float. Okay, it may throw a warning like this, doesn't matter. It depends on the versions which we are using here. Okay, it says that, right, something, it's a warning, that's all. Nothing to worry. So let's look at this D types once again. All right, so now it has to be changed. So horsepower, you see here, it's a float 64. Horsepower earlier was an object. So I just said that as a type of float. So this column is equal to the same column converted into a floating type. Okay, we have an oral question now. Look at the data set, what you have, and tell me what are the features in this data, right? In the sense, features you understand, right? X values. I can use those X values so that I can predict a Y. Okay, what are the features in this data set? So you can see here itself, these are the various values that we have here, correct? Among these, my question is what you are going to use as features so that I can predict something. So what I'm going to predict, that will be Y. I'm going to call that as the target, right? What is the target and what are the prediction features? Just look at this. Anyway, you don't have to look at the complete data set. Okay, simply look at this and you can answer. Just name the various columns which you are going to use as features, like like your X table, right? If you remember our discussion on the fundamentals of this and the maths behind this, the theory section, right? You should be able to remember that there was a matrix X, and there is a column Y, which you call it as a prediction or a target. So what is X? Yeah, please go ahead, Ruchi. Okay, so horsepower, acceleration, fine. Then, okay, cylinders, fine. See, my question is prediction of mileage is the question. So can you include MPG in this? MPG is my Y, correct? Yes, 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 yes. Okay, cylinders. Okay, okay, fine. So basically, you see here, this is the concept. Again, we deviate from here. Everybody can choose their own X values. Anything other than the car name and anything other than our target value, that is MPG, you can choose, right? All any other values as your features, correct? Obviously, I can use all of them. Remaining values, remove the MPG, the first one, remove the car name, that has nothing to do with this. Other than that, how many features you can select? Cylinders, displacement, horsepower, weight, acceleration, model year, right? Origin. Okay. So again, origin, if you see, what is the format of origin? Just look at that. If it is in the text, we cannot. Origin is actually, okay, not this. Yeah, you see, origin is actually a number, correct? Origin is a number, 1, 2, 3, 4, 5, something like that you have, right? You can check the unique values over there to find out what are the different values are there. Now you see, origin could be something like a particular company, maybe, right? Because as of now, since it is already given in the numerical format, we are not able to understand that on what perspective this origin has been given. If origin is country wise, that's also fine. If the origin is has already been created like 1, 2, 3, 4, 5, 6, 7, 8, up to 10, depending upon which company the manufacturer, right, is, then also you can still use that particular column as a feature, right? Because you know that a particular company always produces low mileage vehicle, another company produces high mileage vehicle, so company wise though fine. So definitely yes, origin can also be used. So that's why I am making a comment here. Anything other than MPG, which is my Y, car name, that actually is a text, so we don't use text for the processing or the learning purpose by the machine. Right, okay, hope that is clear. So anything other than this you can use, right? Integer value, floating values are absolutely fine. We can see all these highlighted rows have integer or the floating value. So we are absolutely fine. So yes, you can use anything. So now, as I told, we'll deviate. Take any file. Okay, I'll randomly pick up something, maybe okay, let me choose something like this. You are free to choose your own. Okay, no problem. So I'll call it as X value. So my X value is equal to auto of, I choose displacement. Then let me choose what we have. We have horsepower. Okay, let me also choose acceleration. Let me choose, I think there is a space, right? So there is a space between the model. Yeah, model year. Yes, we can see. Okay, there's a space between model and year. Then I will, let me check what I can use. I'll use the origin. Let's see. I told that we can use origin. Let me use it. Okay, so this is X value, X for me. You can choose all, no issues. But let's do something like that. Everybody, let's choose 555. Okay, so randomly you choose 5, so we can compare our results at the end maybe. Okay, so y is equal to, what's y is only one column. So when you have only one column, so of mpg. Okay, let's look at x dot head. Right, we have x, we have y, you can check y as well. But now what I do, I have my data set ready. Let's split it. X train, X test, Y train, Y test is equal to, you know the function, train test split of the X, what we have, and the Y we have, and go to the test size. So it's again, as I told, it's a standard thing to go with around 0.2, right? 20%. So previously I specified the number itself, okay, like 4. But now you see, I will not specify in that way. I'll specify a fraction, 0.25. 25% of the data you take it as a testing data. Remaining 75 will be your the training data, complete data that is used for training. So whatever is training will come to this, and the corresponding y goes to this. Remaining, right, will be the test. Corresponding y will go to the y test. Okay, so do that. Yeah, train size also is possible. Yes. Okay, you just type TRAIN and then press tab. It will suggest the train size. You can go with that as well. Okay, point bigger number you enter, 0.75, 0.8, 0.85. It will work. Okay, sure. So we have splitted this up. Okay, now again you can check. Let's see. I want to make sure that it's not going to put the values in the same order. Let's check it. Okay, so x train dot, you see it's randomly picking up. So row number 230, row number 345, row number 190, row number, it has to be randomized, correct? Because I think we have discussed this. So whenever you give the data one by one to the machine, right, I want it to be shuffled. I don't want to give in the same order every time. So if shuffling happens, then you see that machine learns in a very wide type of fashion. It gets a lot of options to learn. So in the sense, if I give, see, I'm training my students, I teach the same thing again and again, means that learning may not be very efficient. I have to make changes. I have to alter the numbers in the question. I have to change the questions, bringing varieties in it, so that students can understand, okay, these are the various possible types of question that might come, so that when I give a new question in the test, they should be able to answer. So this is the whole concept. Okay, right. So my data set is ready. What do you want next? Our next object should be, right, bringing in the model directly. Okay, so let's bring the model. So I think we have not uh, we didn't bring the model yet, right? Okay, let's do that. All right, so let's try to do something like from see, this is present, linear regression is present inside the sklearn itself. Okay, so from sklearn, but we are not going to use a pre-processing, or we are not going to use a linear model here. We are going to select we are not using what is called as model selection, because previously we used model selection. Inside that, the train test split was present. But now under sklearn we have a category that's called as linear model. So because our model that we are bringing here is a linear model, so it is kept under linear model. Okay, from sklearn linear model, import, what do you want to import? Let's check. Yeah, so just type lin, then press tab. It suggests whatever it comes. That's, wow, linear regression. So linear regression and its concepts are already built in functions. You can simply call it. Okay. So normally we call it as a machine learning stack. In the sense, what is the procedure? How do you go ahead? All the time, make your data set ready. We have done that. Bring in the model which you want to implement. We have done. Okay, that is present over there. Now you create an object for that particular model. You don't have to call linear regression every time. Okay, so create an object, something like, I'll call it as LR. So LR is equal to linear regression. So now onwards I can use LR, which is an object, right, that actually detects, okay, whenever a user uses LR, it identifies that, okay, I have to do something related to linear regression. Okay, now I have the data, I have the algorithm available directly. Simply you need to do what is called as a training by using a command called fit. You have to fit this data set, has to be fit. You have to fit the data set to your model selected, in the sense, put this data into this model. That's all. So that is LR. LR is linear regression dot fit. If you call this, if you name this instead of LR, you have given a name ABC. ABC equal to linear regression. Absolutely fine. ABC dot fit is what you call. Okay, ABC dot fit. But with what data? I just have to train. I should not use the testing data. So you understand, right? So I am going to pass X train and no, not X, sorry, Y train. I'm saying that, okay, this is the input, this is the output. So X and Y only for the first half, first 80%, 75%, whatever you have chosen, only that I'm passing to. Okay, do this, run this particular cell. You should be able to see, right? This as an answer indicates that, okay, machine has understood, okay, I'm supposed to create what is called as a linear regression. Hmm. Okay, what is the error? Cannot convert a string to float. That means you have not converted one of your feature into float. Your features are still in the string format. What are the features you are using? Can you tell me? Can you name these columns what you have chosen? Can you read the columns? Yeah. Okay. Weight and cylinders. Okay. Weight is integer. Just check. Can you go back and check auto.d types once again, so that there should not be any object present in the whole list. If you have used if you have used something which is an object, it means it is in the any format other than the numerical format. That's one possible reason of getting that error. So it says that cannot convert string. Sorry, int is fine. Int is fine. Yeah, you see, you still have that question mark in your data set. Can you see? You have not removed the question mark. As I told initially, one question, right? You 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 did that. You can you run this command once again on your machine? Yeah, this one. No question mark at all. Then should not be a case, right? Because it says that there is a question mark in your this thing. Okay, could not. Yeah, check once again properly, and maybe that will help you out. Okay. And have you got any error for this command, line number 28? Because here we are converting everything into the float. So that, okay, okay. Then after you type this, you are not getting any other than the car name, no other objects, right? Everything is float or int. Okay. then could not convert a string to float. That it means it's the same. Somewhere you have a string, okay? So that string is not getting, you have not converted that into float. I don't think that happens here, because each one of us using the same data set. So I don't know what's the reason. Okay, just try to explain. Okay, all right. Okay, so this part is actually, you see, training is over. Very simple, right? So that's why linear regression. We start from the linear regression because it is very simple. Easily it will learn, and all you need is to create a straight line. Creation of a straight line is very simple. Machine can do it in no time, right? At the same time, towards the end, when we reach the last part of the machine learning, you will see that this training part is going to run half an hour, 1 hour, 1.5 hour, 2 hours, maybe ultimately 2 days. You will see so much time machine is going to take. Okay, but anyway, it's a very simple algorithm. We are starting from a simple step by step we'll go ahead. Okay, so this is very simple. You called lr.fit for this data. This is my target, fit my model. You ask the machine and machine fit that. Okay, now the second part comes into picture, that is the prediction part. I will give a test data and I should be able to calculate the error, right? So that's our next objective. So the prediction happens like this. Given any name, the predictions is equal to, again you will use the same object name which you have created. Okay, I have created lr dot, the function is predict. Okay, now you have to tell, right? What you should pass here, I'll ask a question, I will not tell you. Okay, what you will pass here, what you want to predict. It's a test data, correct? So I will pass x test. I have another question, should I pass y test here? So see here, for a training I passed lr.fit x train y train. Now I am asking the machine to predict something, so should I pass the x test and the y test? Yes. Okay, we have an answer, yes. Okay, anybody else? Think like that. Think like x test contains my question paper. Okay, it's a question paper. Y test is the answer. Will you provide both of them together? Question paper with the answer. No, right? It's that thing. Yeah, so you see, you are asking the machine to predict something, so you should not provide answer. I will verify later. I have answer here, Y test, which is the right answer. Whatever machine is going to give you will come in the predictions. So I have to compare the predictions with the Y test just to say that, just to decide whether the answer is correct or not. Right? It's that simple. Yes. So yeah. So that's just the thinking process. That's all. Okay. So let's run this. All right, so predictions are there. So for every value that was present in the x test, machine has done some predictions. Whatever it has learned in the previous step, now it has used that, and right, it actually provided an answer. Now anyway, you can check that. You can print predictions. It will give a complete big list. Anyway, it's of no use for us, because anyway we cannot match term by term here, right? Because maybe the y test is some 150 numbers, let's say. Every 150 number I cannot keep tracking, and I cannot keep comparing. Okay, so that's not at all suggested. So what do you do? Write a code to do that. Okay, let the machine only calculate that. All right, so let me try to bring some more parameters. I have to load something more. Okay, so loading is necessary because everything is not going to come in a single step. So there is what is called as, in sklearn itself, we have, see, the performance. If you want to measure the performance, you use various parameters, maybe accuracy. Somebody might use the error, like errors are defined, you know, that mean square error, sum squared error, etc. Many parameters are there, so they are all together present inside a particular block. It is called as metrics. Yeah, sklearn dot metrics. import. You should bring all of them. One is it's mean absolute error, comma. From the same thing, if you borrow many things, you can write with a comma. Okay. So then mean, try to write S for mean squared error, right? I think we have discussed what is a mean absolute, mean squared. I think what was the last term that is used to decide whether the fit is good or not? What is that called? Anybody remember that? R square. Yeah. So you see, we have R2. When you enter that, it suggests R2 score. So we are bringing these three terms. Okay. So just see this from sklearn.metrics, import these things. Yeah, full line. Okay, look at this. From sklearn.metrics, import, then look at this. Sure. Yeah, everything should come in that case. That actually loads your computer's memory, right? If you write something like that, it's if you see import after that, if you see the options available, there are many options. All are not needed, right? So why the Python is fast compared to other languages, because you are able to import only those commands which are required to you. So that's why it may look like why I am importing everything one by one, right? So it is just like, so for that part of the code, I don't need any of the whatever functions I need at a later stage. So I can bring it whenever required and I can use it. Okay, so it's only, that's the approach which is suggested. Okay, when you deal with a larger problem in data science and so on, you will import whenever it is required. Okay, only thing is that you should know where is it, which particular command is present in which side, which particular library you should remember. Okay, so that's one can look like a drawback, but by practice, when you write so many number of codes, definitely you will be able to recall that. Okay, sure. So we have right all these. Let's try to print it out. All right. So everything, it can be calculated in a single step. So I'll just write print. I want to print. Uh, okay, let me write complete mean absolute error. Okay. So what's the short form? Mean absolute error is this. Okay, let me try to write equal to, simply write, there is a function, mean absolute error is the function itself. We just have imported that, right? So mean this of, now you have to tell, how do you calculate the error? Just try to recall, what was the error? How did you calculate the error when we did some maths? I think I remember showing you a table. There is actual value y, predicted value y cap. What you did with that? How do you calculate the next column, that is the error column? Right. So we have, yes, yes, you have done the mathematics over there by yourself by doing the subtraction. But now you don't have to do that. You simply have to tell what are the variables that you are going to consider. The one thing is the truth. That is why these are my correct answer. Compare with this answer, I have to do the, what is that? It's predictions, right? Yeah, predictions. Predictions is the answer machine has given. So use these two columns and tell me what is the mean absolute error is my question. Machine. So machine says that this is your answer. Okay. No, when the table is having only 4 5 columns, manual calculation works. But practically, you will see that the table is going to have thousands of rows. Where even after splitting this into 80/20, let's assume 10,000 rows, it still becomes 2,000 for the testing part. So calculation of that manually is impossible. Okay. So print whatever you want the name equal to, then finish that single quotes and comma, write that calculation whatever you're going to do. Okay, so that's what is happening. Next, I'll write the same thing again. Print. Now I want to display the other one. What's that? It's a mean squared error. So what is the short form? If you remember, MSE. Okay, write that equal to, this is mean squared error. You will pass the same two columns, y test, comma, predictions. Squared error, every term is a square term, so definitely expected value will rise. Then we can define another term. So I can see that this mean of the squared error is a larger number. What people do is we'll take a root of that. Okay, root of mean squared error, RMS. You might have heard about that. Okay, let me print. Yeah, please go ahead. This term mean, what is the error? Can you read? Huh, okay. What is the error? Can you read the error? Come to the last line of the error, because the error will be large. So come to the very last line and you read that. Okay, that means your y test and the predictions are different in size. So one has 10 numbers, other one has 11 numbers, so that it is not able to right. It is not able to make a comparison. It's not possible to subtract or do something. One has only 10 numbers, other one has 11, 12, 15 numbers. So something like that. So just I'm not very sure what happened, because as you can see, it's running very smoothly on this system. So not able to just try to look at the lengths of each one of them. Maybe that will help out, because there is some issue, otherwise it will not throw an error. Okay, system wise, I don't expect something to change for the same code running on a different thing, but still, who knows what could be the possible reason. Just try to find out the lengths of your y train, y test, and the predictions. Okay, try to measure the size. Okay, what is the length? And if there is a difference, that could be the possible, that's the only possible reason. Okay, try that and let me know if you have anything. Okay, I'll move ahead. So the next one is root of the error. I'll call it as RMSE equal to, I have a squared error already present with me. I just have to take a square root. So how do you do that? np dot, what's the command? sqrt. Okay, and inside this, enter this completely. So that is the root of this number. Okay, 3.20. Okay, then we know how to go ahead with the quality of regression, right? How good is your fit, by using the R2 score, right? Print. So how do you find out R2 score? Just try to find that. So R2 score equal to R2 score of y test, comma, the prediction. It says 0.799. Okay, maybe 0.8. What's your comment? Is it a good fit or it's a bad fit? Zero, it's 0.79, correct? Not zero. Huh. No, 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 no. Read it once again. Read that point wherever you said I told one or something. You read, if possible, if you have that document, read it again. Okay, because I never said that. I said a slightly different version of that. So if the possibilities of R square is only between 0 and 1, there is no question of going beyond 1. So if it is closer to 1, it's a good fit. If it is closer to 0, it is bad fit. So now you decide that and tell. Compare it. Yeah, at least may not be very good fit, but moderately good fit, right? It's closer to 1, right? Now I have to justify. I have to say that so previously I simply said that okay, this is the equation, you calculate r square is close to 1, it's a good fit, r square is close to 0, bad fit, everything is fine, it's proved one, but still I have to prove this to you now, right? So let's do this. uh, let's Prediction has been done. Okay, prediction equal to done. Okay, now let me show you something. Okay, let me try to print something. Let me try to the predicted value, right? I had an X test. I passed the X test to the machine, right? It gave you a list saying that, okay, these are my predictions. Now let us compare the truth and the predicted value so that I can justify that, yes, machine has predicted approximately, right? I told that this is a moderately good fit, correct? So I have to justify. So let me go with this PRED dot, sorry, let me go with the, I have so many numbers, number of data points. Second number, let me check the second, sorry, 012. So this is the third number. I'll check. It says not PID. What's the name? My mistake. I didn't type it. It's predictions. Correct? It says 29.65. Let me check what was the right answer. Correct? This is the third question. Like I had 100 questions I gave to machine. Machine gave me 100 answers, out of which I'm checking the third one. This is the third answer machine gave me. Now I have a list containing the right answer. I'll compare. Okay, so how do you check that? That is y test dot, if you just type this y test of 2, it will not display it. You have to check values. Okay, y test dot values. In that you check the second one. So you see, it's 29, or right answer is 29. Machine gave you an answer 29.65. Now this is why I said, right? The answer is moderately matching. May not be exact one, may not be up to the values of two decimal places. It might not be the case, but yes, close enough answers you are getting. That's why the answer came to be 0.799, approximately 80% or zero point 0.8. So that's why I mentioned that this is a moderately good fit. Anything more than 0.85 to 9, that becomes a good fit. Okay, you get up to two decimal places, close answers. But if the value is lesser than say zero point 0.5, zero point 0.4 or something, you will see that many values will have a huge difference. Answer is 29, you get a 46, right? Those kind of answers will come into picture. So that's why I said R square value is the particular equation you just refer, how it calculates, etc. Same thing has been implemented in the Python. So it will actually calculate the using the predicted values of y and the actual values of y and the mean value of y, it calculates that. Okay, so that's about the implementation of the linear regression in a very simple fashion, considering a very small data set. Okay, if you have any doubt, please go. Okay, so that's good. We'll take a quick break now, and we'll come back and we'll discuss some of the other important aspects, and such as the what is the stochastic gradient descent, right? What are the various types, etc. We have discussed that in the theory part, but practical implementation, I want you to visualize, right? What do you mean by that? Step by step coming down means what, right? I want you to visualize that. So that's what is going to come up in the next session after the tea break. So we'll meet at 5:50 and we'll continue. All right, please take a break. Yeah, this part. Okay. Yes, Ruchi. So heat map actually tells you what particular feature is correlated with your answer, such as you see here. Uh, See 0.56 MPG and origin are, there is a correlation of 0.56, indicating that they are highly related, highly correlated with each other. Okay, in the sense, if you want to say discuss, or if you want the machine to predict your MPG, you have to go with the origin. Okay, that's one thing, right? Look at that, whichever is red you have to use. This is what I suggest, but anyway, as I told, in this particular context you can use anything. Okay, any other feature also fine, but you can decide which are the features that are highly correlated with your output. You can decide, such as you see for MPG, right? So you can see origin is highly correlated, model year is correlated, acceleration is ah, yeah. So that is what highly correlated features are expected to be selected. Okay, even if you consider others or you leave the others, may not matter, but you have to consider these. This is what is the ultimate. Okay, sure. So far we were discussing about the implementation of the linear regression using the scikit-learn tool. Very few of the instructions or the functions are required to be imported from the scikit-learn. As the scikit-learn is a huge tool, and uh, it can help us in implementing almost every type of the machine learning algorithm. Right? We will not import everything. We'll import part by part as and when required. Okay, so that was the first part. We have completed that, and now let's move to the next part. Okay, so we will move into the optimization part. So optimization, in the sense, there is a term called loss. So the loss actually begins from, right, a higher value at the initial phases when the machine is starting to learn. But as the time progresses, we will see that the loss is reduced, and when the loss is minimum, we will say that yes, machine has learned something. Okay, so this was the concept. Even in the theoretical section, we try to understand the same concept. All right, now it's a time to visualize that what exactly is going to happen and how the gradient descent is going to help us to achieve our target of minimization of the loss is our topic of discussion today through the program. All right, so let's import all the various, what you call, libraries required for that. We have the NumPy, we have the Matplotlib, and the pandas available with us. The one more tool that we need to bring in is called as a SciPy. Yeah, sure. Which part you want to see? This one? Okay. Yeah. All right. Sure. So we'll bring in a particular tool called the SciPy as SP, and then I'll say import. In the SciPy, I want to bring dot optimize. All right, optimize as OPT, because my intention is to solve the optimization problem. So I have to bring the supporting functions wherever it exists. It's actually present inside the SciPy. All right. So to start with, let's try to define a function. I need a function which actually has crests and troughs like that. There should be a maximum, minima, local minima, global minima, etc. Should be there. Mathematical terms I'm trying to bring in over here. So define, let me say this is a function. I'll simply write f of x. X is my parameter which I'm trying to pass. Okay, this is an argument. Now I just have to return 1 minus, I'll just write np dot sine of x, okay, sine theta by theta. So it's a sinc function. Standard name for this particular function, sine theta by theta, is called as a sinc. All right, so 1 minus sinc is what I'm trying to do, right? How does it look like? I'll show you in a while. So let me create various x values. So I try to create a linear space starting from minus 20 to plus 20, 1000 point. Okay, that's the x value. Y can be calculated as f. I call the function f of x. And okay, let's create this first. Let's see whether we have an error. So invalid syntax. Oh, my mistake. Sorry about that. It has to be a comma. Okay, all right. So we have y created according to the x values. We have created a y. What is y? Function of x. That function already has been defined in the cell number 48. Okay, so the next step is to visualize that. Let's go for fig comma ax. Figure and axis I'll try to create directly. So how to do that? It's plt dot, so subplot. I'll try to create a 1 comma 1 comma, it's a small fig of a certain size. So fig size size, okay, equal to, let me try to write it as say 5 comma 5. So I create this and I directly say that ax dot plot the x value and the corresponding y value. Oh, mistake. What happened? PLT is not defined. Subplot takes x dot subplots. Oh, subplots, right? Let me check. Okay, so it will generate a graph for you. Okay, so when it comes, I'll show you that. Okay, you may get a graph earlier. That's fine. Just see that it has to have many crests, trough, and one very lowest possible value called as a global minima, something like that. That's what we are expecting here. Okay, so now our intention is that you can consider that I have to reach the lowest point, right? That's our goal. Let's say that this is what is our loss function and I have to reach the minimum point, right? So whenever our target is to reach the minimum point, we have to use the optimize problem, right? Optimization that we have actually, right? We loaded that, we imported that. Inside this optimize, we have a minimize function that is present. So we are going to use a minimize function that is present inside the optimize scipy.optimize. Now there is a condition. You have to tell, in order to use this minimize function, you have to specifically tell that from where you want to start. For example, okay, I think I am not able to show you that output because I didn't get output yet. Let me wait for say 1 minute or something. If it comes, it will be beneficiary for us. Otherwise, I'll ask someone to share their screen and we can discuss from there. Okay, so let us say sorry, which one? This one, a ax dot p plot dot, it's not pld, it's plot. Okay, so just check that once. Right now I'm calling a function to plot. Okay, so maybe if plot you change it to plot, it will come, I guess. Okay, You can see the sync function. All right. I will stop sharing. Kindly share your screen. All right, so that we can discuss about it. Okay, so I'll stop sharing from my side. Kindly share your screen and we'll discuss. Yeah. Okay. So I hope everybody can see the screen, right? Now, see, this is the idea. So you can see that it actually, right, it begins from a point, goes up, goes down, goes up, goes down. Those are the local minima. And there is at the center, maybe at x equal to 0, horizontal axis 0, you can see a minimum point coming. That's what is considered as a global minimum. So mathematical term, if you have studied the analytical geometry, right, these terms are very common. Okay, but now what we are trying to do here is we are going to use a function called minimize. So the minimize function takes a function as input, that is this f of x, that is y, and I have to tell that from where I am supposed to start. In a sense, you see, the minima that you are going to reach depends upon from where you start. You see, if you start surrounding zeros, in the sense close to zero, maybe it is 1 2 3 or even 4, or on the negative side -1 -3 up to, let us say, minus, close to -5 and +5. If you start between that, you will end up coming to the global minimum. But if you start at any other point other than this, right, let's say I start from 6, you will end up at a different minima because that's on the other side, right? It may not be the global minima that we are looking for, it may be the local minima. So you see here, you may end up local minima or global minima depending upon from where you start. Okay, so that's the point here. All right, so let's do one thing. Let me share the screen. Thank you, Ruchi, for sharing the screen. Let me share my screen again. Okay, so now I will try to define what is my initial point. Let me say I want to start from, let me call it as x naught. X naught is equal to 3. Now you know from where you start. If you start anywhere between -5 to +5, I am expecting to come to the global mean. Okay, so this is 3. I can expect to come to the global minimum. X min is equal to, this is OPT dot, we have given a alias called OPT dot, this is minimize. See, you have a function called minimize. You just have to tell this is my function, whichever is a function, that is f, what, from where you want to start, that is x naught. Okay, and you will tell these are my variables, and these are the x values I want to pass so that I can calculate a minimum. Okay, so I'll say x. Okay, so let's see, right, what happens to the x minimum. Right, you see it is actually very close to 0, 10 to the power -8, right, close to 0. We are expecting exactly at 0, but it says this is the x value where you get a minimum. Okay, now let us try to plot this and see, right? I'll try to visualize this whole concept. I'll also try to mark a minimum point that the machine obtained. Okay, so let's try to visualize that. Starting from initial point x naught equal to 3, we started from there, we reached the x minimum that is close to 0. What is the y value? That we'll try to find out and we'll try to plot it as well. Okay, so let me try to go with another figure. So figure comma axis equal to plt dot the plots 1 comma 1 comma figure price equal to, let me write 5 comma 5. So this is the same statement we wrote earlier. Ax dot, it's a plot. I want the original plot to be present. Okay, so I'll call it as x comma 1. The same plot which we have plotted just now, it's there. Then Ax on the same axis, you give me a scatter plot. Okay, give me a scatter plot corresponding to the x naught, whatever is the x naught value, that is the one initial value, comma the function of x naught, right? at x equal to 3, what is the y value? Plot me that. All right. So that's what I want, comma, I can say give me a marker value. So marker is equal to, you can specify, I want a circle, so I'll write O. So in the sense it will mark as a circle. I want it to be a large circle. So what I do, I will specify the size. S is equal to say 200. You see 200 pixels will be considered okay. Okay, so that's the thing here. You can, if you want a bigger size, make it 300, 400, 500, whatever. Okay. Then I will also plot that is AX dot scattered. Now we see there is a minimum point. Already machine identified that this is the minimum point. How do you represent that? It is x min, right? Already we have calculated that. Comma, I want to see what is the y value. That is f of x min. Okay, this is fine. And I want a different marker. Okay, let's say marker. Sorry, not market. My mistake. Marker is equal to, let me say b. This is going to give you a triangular marker, and I'll try to get x equal to say 300. Okay, let's see what happens. I still didn't get the output for my previous command, that is line number 52. I don't know whether I get 55 or not. Okay, so meanwhile, if yeah, any one of you have got this, kindly share it. Okay, I will stop sharing. Please share your screen. Okay, now you see the markers are visible. The red colored marker, circular marker, which you see on that, right? That is the point where it started. X not equal to 3. If you read the x value corresponding to that point, x equal to 3. Why we don't know, but a particular value f of 3 is that value. Okay, but what is the minimum point? You can see a triangular marker over there. The triangular marker is located close to 0 on the x-axis, and its y value is the minimum value of the whole curve, right? Uh, right, on a global scale. So we understand that this is a function, right? Minimize is a function which is, right, used to find the minimum, but this depends upon from where you start. For example, if you start from a different x naught, say, let's do one thing. Next objective is that repeat the same thing. I'll give you a small work to do. Start with x naught equal to 10. Same thing, everything you have written, same thing, copy and paste in the next cells, and try to do this. Okay, so make x naught equal to 10. Only that's the change. Remaining remaining lines will remain same. So x naught equal to 10, x min equal to optimize part. We'll do that. Okay, uh, then call the same thing again. Okay, the whole plotting function also you copy and paste as it is. Okay, now what you are going to expect is that you are starting from a different x naught. So since you will start from a different x naught, you will reach a different minima, because initially we understood that the minima that you reach depends upon where you start, right? Now you started from a different position, you will not be able to reach the global minimum, but definitely you will reach a local minimum. Okay, I hope that point is clear. All right. Okay, yeah. So thank you, Ruchi, for sharing it. Fine, let's go further. The next concept that I want to bring in here is the gradient descent itself, right? So far we didn't touch the gradient descent yet. Gradient descent shows calculation of a gradient and coming, right, down step by step, right? Right now that part has not been discussed. We discussed about using a inbuilt function present inside the optimization part of the SciPy to come to the minimum point. All right, so let us try to initialize the parameters that are required for say for our algorithm. All right, let's say I will start with, okay, I'll say this is the current value of x is, as we already have started from 3, I'll start from that. Okay. Now you see learning rate. If you remember, learning rate is something like if I am at the top of a hill and I want to come down, right, without seeing anything, right? That means what I do, I'll try to, right, maybe I'll try to take a 360-degree turn. I'll try to identify where I have a deepest slope, and then I'll try to take a step. So that step which you can stay, which you are going to take, is your normal rate of walk, let us assume, right? So that is what you are defining here. This is a hyperparameter. So rate, I'll try to define this as a rate. Rate is equal to, let me keep it as small as possible. Okay, so maybe I'll try to keep 0.01. You can go much below this, but let's see. Let's stick to this. Later on, you will try to you should try to change this value and see what effect, what is the effect on the whole algorithm. Okay, then now let us say, let's try to tell a value. Let's try to define a value which is something like a standard value where the learning algorithm should stop. Okay, so I'm going to call it as, say, precision. Okay, this is equal to, let's try to define as 0.0001. Is much smaller. Okay, and right, what is the change in x that you support? Because x starts from 3, you can increment or decrement by 1. Okay, so let me try to define it as the previous step. Okay, the step size is always 1. Okay, and let me also try to put what you call as a limit on the total number of what you call iterations. Okay, yeah, meanwhile we have a question, I'll come to that. So what's the range of learning rate? Yeah, 0 to 1. Okay, and yeah, it can be 0 to 1. Okay, so 1 is the maximum. That's what you see here as what you call the previous step size, right? So that's 1 in the sense something like a maximum. So then I'll try to define the next term that is actually called as, it's a limit, maximum number of iterations. So you can think that there is a restriction saying that you cannot take n number of steps. The number of steps you take is, there is a limit, right? So, something like you are at the top of the tower, you have to come down. There is a restriction saying that 10,000 steps. Otherwise, what people do, people right, try to put as small as possible, and they take a lot of time to reach them. So after 10,000, wherever you reach is your final position. This is something, right, a restriction over there. That's what we call as maximum iterations. And right now the number of iteration, right now you are at the 0th iteration. You have not started anything. And let's try to define a gradient function here. It can be anything, but right now I don't have any function with me. I will define that. Okay, so this is df is equal to, I'll try to write 2 into, let me try to write, this is x plus 5. Let's say, this is again, right now I'm assuming, if you have a function in mind, you differentiate that. That will be this function. Okay, so df equal to, okay, I cannot do that, sorry, my mistake. I cannot write like this. It has to be lambda, right? Lambda x equal to this. In the sense, wherever I give a x, df equal to 2 into x plus 5. Okay, that is a gradient function. So this actually is your df. If you have a f, df by dx you get this as a function. Okay, so any function in your mind, you can take its differentiation and you can write it. So these are the parameters I am defining for the gradient descent algorithm that I am going to write from scratch. Okay, right. Now, what are the conditions? Under what conditions you will go to the next step, right? You are at the top, or you are at the middle, or wherever you are, right? You are, this particular condition that I'm going to apply now is valid irrespective of your position. So what are the conditions? Just try to relate what I told initially. I told that, okay, these are the conditions. Now I'll repeat that. while you meet these conditions, what are the conditions? The previous step size is actually greater than the precision. Okay, and number of iteration, the current iteration size, I think I call it as ITR. Yes, okay, iterations are lesser than the maximum number of iterations, right? Under these conditions, right? So step size should be greater than the precision. Precision in the sense this could be the last value you can reach. So the step size, I will show that step size keeps on changing now. So it has to be more than the precision, because precision is something which we have written, that is the smallest value which the step size can take. So under these conditions, okay, now you tell. Let me start with what is my previous position. I'll say that previous position is the current position, because when I take a next step, I'm here, I take one step. So the current step will become my previous step. Okay, so previous, I'll call it as say x equal to, I think I call it as a current x, cur underscore x, pretty much value. Assume that I'm taking a step. So what happened to the current? What is the current value? Current x is equal to, it is the present value plus or minus something, right? Assume that there is a possibility when you are climbing down, you may get another slope, right? Everywhere you have a uphill, but you have to take a step now. You cannot go back. So you will take the uphill, which has a least what you call slope, right? Because most smallest slope is what you are looking for, right? So in that case, this can be plus also. So I will write an equation in that format, but anyway, it should be understood. So the current value of x, but I'll write a minus here, because always, let us assume a very simple problem. I'm descending and I keep coming down. So current value is equal to current value minus, so take your rate into the function, that is df. Df is actually a value you obtain depending on your previous checks, correct? So right, so look at that. So just try to understand this question. If you remember, I had written a particular equation for gradient descent in our theory class. If you are able to open that, please open that and see. You have a very similar equation like this: wi plus 1 equal to wi minus a eta value into df by dx, or dw by d theta, right? So there is an equation like that. This is the same equation. Okay, this is the only equation that is applicable for gradient descent, and I'm not changing anything out of it. According to my problem, I have substituted the values. Other than that, everything is pretty much straightforward. Okay, so that's what is going to happen in, and I'm going to the next step. So my current step gets updated. All right, now I have to change my step size, right? So that is equal to, so previous step size should be equal to, I'll take an absolute value. Okay, so see, this is the error calculation, that is the current value of x minus the previous value of x. So current minus previous, and take an absolute value. That doesn't matter, you increase decrease doesn't change now. So taking only magnitude will come into picture, right? I have this, and I'll ITERS equal to ITERS plus 1. ITERS plus equal to 1. It's a shorthand notation. ITRS equal to ITRS plus 1. This is what I'm trying to do now. Then, in order to visualize what is happening, I'll put a print statement. Okay, so print. I'll try to type the iteration. Okay, iteration, comma, ITERS. Then I'll also print in the next line x value is equal to the current value of x. Okay, so this is what happens inside this while loop. And let me try to write the final value. Print uh, occurs at what I should write, the current x. Okay, so let's visualize what's going to happen now when I run this, right? See here, iteration number 1, it was starting from 3. How you decide it is 3? It started from current value equal to 3. Okay, but now you see, after the first iteration 2.84, then 2.68, then 2.52, then like that. You can see that so many number of iterations took place, right? And at the iteration number 367, it reached a minimum like 4.99. So either of our conditions met. What are the conditions? The previous step size either became equal to the precision, or yeah, okay, not this condition, because I think we defined the iterations as 10,000. It never reached 10,000. It's still at 370 something. So this is the condition which met, and right, it came out of the while loop, and it actually printed the last sentence which we said. So the minimum occurs at x equal to this. So indicating that after 367 steps, starting from the top, right, which was having a value x equal to 3, now the x value became minus 4.99 and you reach the minimum point. Okay, right? So some function we have defined, and right now you can see that the function tries to find out what is the value of x for which the y becomes minimum. That's all. Okay, you have any doubt? Please go ahead. Okay. Yeah, sure. I'll come back. So df is actually, it is a function. Okay, the function df is a derivative of your actual function. So you see, you have a previously I actually have plotted a function, right? That similar to that function, it's not a function, it's a derivative of that function. Why you need derivative? Because the equation of the gradient descent has a derivative term in it. Okay, so it's like your next weight value equal to current weight minus there is a learning rate eta into df by dx, okay, or df by d theta. So that df is what you are writing here. Okay, so that is df. You can see here, multiply by a rate which is a learning rate for us. So eta into df by dx is represented by this. This is the eta into df by dx. But here dx, I'm not taking a derivative. I already write the derivative directly. That is this function. What is the derivative of that function? It is 2 into x plus 5. Okay. So lambda is called as, you can write lambda functions as a special function. Whenever your input is only one value like x, you can try to write a function using lambda. It's a function that is available. It's a functionality that is available in Python. You can write what is called as a lambda function. Okay. All right. Now, everybody look at your chat, and I have sent another data set to you. Okay. So using this data, we try to explore something called as, yeah. So we'll try to explore further and we'll try to understand more about this gradient descent. Okay. So it's a text data, txt. So what I do, I'll try to read this directly. Okay, whoever receives first, please put that into your I think the group in WhatsApp, so that everybody, those whoever is not able to see that, can collect that. Okay. Meanwhile, I'll try to write the first part. The data is equal to, it's from pandas pd dot read CSV. Okay, I'll just copy the name. It has a very large name, but don't worry. So just see here. This is the complete name. You can copy from the name of that particular file. It's a simple pendulum oscillation data. Okay. Then there is a separator. Separator we use is a space. I don't want to use any header. I want to give the names as L and T. L is the length, T is the time period of oscillation of the pendulum. Again, this is a very small data set, right? We'll visualize that, but first, everybody just write this and enter. Okay, I'll show you the code from the beginning once again. So data equal to pd.read CSV. Inside the double quotes, write the name of that completely .txt, that's the extension. Then you see the last part. Separator, what's the header, what are the names of the columns that I want to. Okay, do that. Then I'll look at the data. So dot head. Say we have 30 seconds to do this. Everybody, please do till here. Sorry. Okay, so you can get the help of the read CSV to get the complete details, but I'll tell you what we are using here. Okay, so the separator, if you look at the text file, there is a separator called, in a sense, how do you want to separate your data? Because it's completely written. Text says that 1, 1.5, 2, 3.5, 3, like that. What is the separator between your data? It is a space. So I'm saying that the separator used should be space. Once you find a space, next to whatever you see is my next data. So separator is that. And in the whole data set, there is no header for that. So I'm saying none. In my data, I don't see any header, no column names, etc. present over there. That's what I am supposed to tell. And then you see what if you, I can see that there are, right, two values. First value should go to L, next value should go to T. Okay, so L means it's one column. I'm giving a name of the column as L. That's the length of your pendulum. And T is the time period of oscillation. How much time it takes to finish one complete oscillation. So if you remember physics, there is one particular relationship between L and T. Anybody remembers that? Are you able to recall what is the relationship? How L and T are related? L equal to T, L equal to minus T, L equal to 1 by T, like that. I'm expecting a relationship. What do you see? Okay, okay, no problem. If you don't have physics, no worries. I nothing to do with that. Anyway, I can search in internet and I can find this answer. Okay, so I'm not. L is the length of the pendulum. T is the time period of oscillation. Okay, so how they are related? I'm asking to only those who had some physics knowledge in the past. Okay, but that is absolutely not necessary to solve this problem. Okay, but I'm simply trying to explore, right? So that can I relate something? So L equal to minus T. Okay, T raised to the power minus e to the power. Okay, exponential. All right. Okay, one answer is e to the power minus T. Length should be like that. Okay. Okay, any other answer? All right, so I'll tell you the actual answer. Length is proportional to square of the time period. Okay, so L proportional to T square. Okay, so that's the relationship. normally it is expected that even if we don't know, right, you try to look at whenever we have it, if possible, in a data set. Normally when you have many number of columns, it is not possible. Okay. But you have a very simple data set like this, only two columns. One should be related to other somehow, right? Otherwise, it may not be possible to relate one to other. So normally you can expect some relationship you can try to find out, again, if it is possible. So if you collect a data, very standard data, like if like some physics experiments or doing some experiments in some other field, like chemical composition, etc., that will definitely have some relationship between the variables, right? So it is expected that you can try to find out somehow, or if you know these are my standard variable, you can refer internet and you can find out that. Okay, so like this. So in this case, you can definitely search and you can find out how the length of the pendulum and the time period of the pendulum are related to each other. Okay, so what we do now, let's go to the next step. I'll try to define that L is equal to, inside my data, I have to create this L and T in the previous step, because otherwise the handling the data frame is not possible, because you handle the data frame with respect to the name of each column, correct? So that's why we gave a name in the previous step. Names equal to L comma T, we purposefully have written, because of the reason being, I want to, right, know that, okay, this is the L, this is the T, I can access those values by L and T itself. Okay, so you can see here it's a data of L, and I'll tell that it's the values dot, so no space, why it's not coming, values, yeah, so you can see values, that's the L. And I'll also bring the T here, so T is equal to data T dot values. Oh, my mistake. Dot values. Right. Now what I do, uh, I'll use the same property which I know now. I could understand, either I might have explored the internet to get this relationship, or I already have studied, or I did an experiment to, right, observe this. So I'll write TSQ, the square value. So TSQ is equal to every time value you have its power. So T into T, let's say. Okay, these are the values which we have right now with us. Now let me try to write a function so that I can try to perform what is called as batch gradient descent, right? So previously it was a general a function which we have written here, and we try to understand that. So the next step is to go with what is called as a batch method. You give your complete data set at once, and you will be able to do the updation in that fashion. Okay, so let us try to do that now. Let me try to define train. I'll pass my x values, I'll pass my y values. Okay, you see we have, it's a actually a straight line. I'm trying to perform the linear regression. Linear regression in the sense, I am supposed to fit y and x using m and c. M is the slope, c is the intercept. So let us say I start with the m value, I start with the c value, I pass them, and also I'll pass what is called as the learning rate, that is eta. Okay, so let's say I pass these values, and I expect the machine to train. Okay, I expect the machine to train. Okay, so let's just try to start this now. Let me define something. I'll justify why I'm writing this at a later stage. Okay, so that is, let me try to define a constant term that I'm going to use for calculation of the gradient. Okay, so gradient calculation, that is it's a dou something, dou f by dou s, that's the gradient part. Okay? So you can try to define a term. All right, so that is, let me try to define, it's a constant. Constant is equal to it's -2 divided by length of y. Okay, what is y? Y and x I'm trying to relate, right? Y and x I'm trying to relate now. What is y? What is x? I'll pass now. I'm still writing a training algorithm. Okay, so this is the one which actually implements our gradient descent, and we'll be able to use this function. We'll call this function with the practical values like our L and T. Okay, so we'll try to relate that. Okay, so that's my ultimate goal, but right now I'm trying to write a the manual code. Okay, so this is my first term. I'll come to this at a later stage, don't worry. So let's say this is the constant term that is related to our relationship. So there is something like y equal to x square if you have. So x becomes equal to, right, root of 2. Take a differentiation of that, and then we are coming to this. So there is a term -2 coming into picture. That's the constant term. Okay, so we'll come to that at a later stage. Don't worry. So y calculated value is equal to, how do you calculate y value? Y is nothing but this is m times x plus c, straight line equation. We are trying to fit a straight line for our data set. Whatever data set you have, we are trying to fit something like this, right? Because linear regression using the batch gradient descent is what I am trying to do. Okay, that's fine. Now m, there is a m value which is a parameter, and c is another parameter. Like if you relate this to our theory part, theta 1 and theta naught. Theta 1 is m, theta naught is c, correct? So that actually changes. Dou theta 1 by something, dou theta 2 by something. That's what we have calculated, right? So we are trying to write that. Let me call it as delta m. Delta m in the sense change in m. That is equal to the constant that we have calculated into, it's a sum of every x value into the actual value of y, okay, minus the calculated value y calculate. Okay, y calculate, just now it came for a given x and y. We calculate y equal to mx plus c, but m and c are not the optimum value. M and c are the current value. From the current value, I have to calculate the change in m so that I can update the m. This was the same case like previous case. I start from here, I give one step, I calculate a change in step. That is this delta m. Okay, this change in the step, if you calculate and add or subtract to your previous value, you get your next value. So that's how m gets updated. Okay, but it is not valid only for m. It has to be applicable even for c, delta c. Now you see we have two parameters. Previous problem was very simple, only one parameter. Updation was very simple too in our mind. But now you see updation happens for two different parameters, theta 1, theta naught. In this case, it is m and c. Okay, so delta t is equal to, once again, the same constant value. I'll multiply that to the sum of, right? Why you are taking sum? Why not y minus y calc only? Why not just x into y minus y calc? If I do that, this is going to be a single calculation. In the sense, one term is given, machine takes one term, I'm updating. That is not happening, right? That's not the case. Batch means complete, right? Everything you have to take. That's why, how do you consider everything taking the sum? Okay, so that's why the sum comes into picture. So very fundamental differences between batch, mini batch, and the stochastic part. Okay, we'll come to that. So this is x. I try to it's the same function. Okay, so into this is y minus y cap. Okay, so let me try to write it this way. Okay, this is the change in the sense there was a c here. C calculates say delta c. So if the delta c is larger, you take a bigger step. Delta c is smaller, the small change in c. So I have to do that now. Same thing happened with the m also. M was somewhere else, maybe here. M calculated a delta m like this. It has to change by this much amount. So for this m, add this difference to so that you get the new value of m. How do you do that? This is m. Yeah, please go ahead. Sorry. uh, y, yeah. Thank you for noting. Sorry, my mistake. I don't need this. No x. Okay, they're not same. Thank you for noting it. Okay, it's just sum of y minus y. Okay, so because only this y is responsible for finding out the y-intercept. Right. Then my intention is to calculate this m. M is equal to m minus the delta n, delta n into the learning, right? Into the learning rate, we call it as eta. Okay. Let's go ahead. Let's also try to calculate this c. Okay. C is equal to c minus delta c and multiply that with eta. So now you see this equation you are very familiar. Weight is equal to next weight is equal to current weight minus the eta times, right, df by dx. So that's what is happening. The df by dx is represented by the delta. Okay, then calculate the total error. That's the once this is done, right? I have taken already a sum, so now you will be able to calculate the error. So error is calculated for like this, the sum of, it's a squared error. Again, you can calculate any type of error. Let me stick to the squared error. That is y minus y calculated value. Let me raise it to the power 2. Okay, and there is a divide by m, right? So how do you divide by m? That is nothing but how many number of points you have, you need to consider. So simply divide by the length of your data, that is y. Okay, once this is done, you need to return something. So return the m value, the c value, and the error one. So these are the three things that you are supposed to return to the calling function. Okay, so that's a thing. And now let us start with the. So this is the function which calculates, which performs the patch stochastic gradient and returns you an answer. But I have to pass the parameters and I have to call it, right? So how do you call it? Let's start with, let's say errors. I'll call it as a one type of error. Error one is equal to create a list, empty list, m c equal to initialize both as 0, 0. Okay, initial values. You can start with -1, +1, 1 and -1, 1.52. No problem. You do whatever. Okay, learning rate, let me put it as say 0.1. Any value 0 to 1 will work. Okay. Okay, now what I do, I will call this train function many times. Right? So the previous case was I defined something like while loop I use, but now I want to show you how to do the same thing with the for. Again, something new to learn. Okay, so let's go for, okay, let me run this part first. Then in the next cell I'll write say for I iterations in the range. Let me put a cap of 2000 iterations. You can change it, you can make it a larger number. Okay, so in this particular range, what my function returns? My function returns n, my functions returns a c, and function also returns error. So this is equal to, simply call train function. Just now we have written that, you can see there. Train. What are the parameters you are passing? What is your x value? That is the length of the pen. What I am trying to expect is the square of the t. I don't remember what was the name. Yeah, ts. Yeah, so that's what I want the machine to expect. Okay, because length and t square are proportional, so I am calculating t square, then I can take a square root to guess my t, right? So ultimate objective is length is given, calculate its t is the question. So Now, so far I have no idea. I cannot use the direct equation, because if you give a direct equation, it's not machine learning, correct? You cannot give a root, right? So you are asking the machine to find out the root. So machine should be able to, for a given L value, machine should be able to calculate it. So I know that I cannot give a T and I cannot ask the machine to learn. I can give a T square because there is a relationship, right? So I'm giving something like that. Okay. And I pass a M value, I pass a C value, I pass the eta. So these are the things which your function expects. X, Y, M, C, eta. I'm passing X as L, Y as TSQ, M, C, eta are passed. Okay, so this happens how many times? This happens 2000 times, and every time it calculates an error. So what was the name? Errors underscore one. I'll update. I'll each time the error comes, I'll append. Okay, so to the same list. So this is equal to yeah, no need to write equal to dot append the error. Okay, then okay, let me run this part. Train delta m and delta c. Let me check. Delta m is equal to this delta c. Okay, so let me run that again. We run this and let me run this. Okay, and let me look at the final values. M1 C1 is equal to, you can see I'll put m comma c over there. Okay, I'll try to print out those values. M1 equal to, this is the slope of the straight line, and the intercept is this 0.073. And what I try to do, I want you to visualize. So far I said that, okay, this is what happens. This is how the calculation happens, I just do. But now my intention is that I have to justify that this particular algorithm called batch gradient descent is going to give you a right answer. How do you do that? Only possible if I make you to visualize. So what I do, I try to plot the straight line. I will also try to plot the points that we have right from the data set. Okay, so let's plot that and let's try to understand. Okay, let's try to write this. So y1 is equal to, this is m1 times the length of the pendulum, mx plus c, x is my length, plus so c1. Okay, this is what I am creating now. So these are the y values. I'll try to plot them. Okay, so that is PLG dot. So first I'll try to plot the length of the pendulum, TSQ, comma. Let's try to give a dot K. I want black colored K. Okay, that's the first thing. PLG. Say I'll pass the length itself. Length itself is my x value, but y changes now. Y is the one which the machine calculates. Okay, that is y. And let me try to make this as a, say, green color. This will be a straight line. Okay, the L comma y1 will be a straight line. L comma TSQ will be dots, because those are the points we are reading from the table. Okay, this is what happens. Okay, I don't want any name for X label, Y label. We understand. Okay, so directly I'll call the show PLP dot. Let me see. Oh, my mistake. What happened? Yeah, you see, it's coming with the previous one. So just let me know if you can see a straight. Ah, yeah, this is it. So previous outputs came all of a sudden. All right. So now you see the dots. They are the points read from the table itself. Okay. But now the straight line which has been drawn here, machine actually has estimated that. So these points lie along this particular straight line. So that is a justification saying that, yeah, so whatever you have done, this is the answer. So for this data, this is the best fit. Linear regressed straight line is this. Okay, do we have any doubts so far? Please go ahead. Yeah, yeah. Sure. No problem. Okay, so this from here. Okay, please go ahead. Yeah, Devendra, go ahead. Yeah. Hmm. No, actually, no need to remember. Okay. So every you see, you have done a lot of code. That's fine. But initially, this looks like, maybe this looks like I have done a lot of code today. But strictly speaking, on a machine learning project level, if you see that, this is nothing. This is just 1%. If you take an actual machine learning code, right, something like classification of say 1,000 different image categories, something like that. If you go to that level, that's a practical application. This whole code, what you did in today's 3 hours, is something like just 1%. That's nothing. That's, again, I'm not saying that what we have done today is nothing, but comparatively, the size wise I'm talking, that's very small. So how to remember, you told, right? The remembering of every concept in terms of theory is important first. So because if you look at the theory part, equation comes into picture. So irrespective of which programming language I use, the concept remains same. I just have to remember that, okay, this is my fundamental equation that I'm trying to implement. So you can see here the same thing we have done today. So ultimately, calculate the changes and update the values. This is the ultimate thing. But in order to do that calculation, maybe you require something else. Okay, so for that we need something else that is coming from the thing. So out of the whole code, normally 25 to 30% will be making your data set ready. Like, you collect the data in today's session, every data was readily available. You didn't have to do anything most of the time, right? But in other cases, data processing comes into picture. Generalize it as a data manji. You have to make modifications, you have to visualize, you have to plot and understand. So that will take generally first 30% of your code. Okay, so remember, that is very important. So you can go back to the pandas, you can go to the numpy, you can go back to the various plots available and try to recall. So that is the first part which you need to remember. So since you asked the question how to remember, so I'm coming step by step. So go back and understand, at least you should know that, okay, if I want a plot like this, there is a command like this. No need to remember everything of that command, but you should remember that there is something called as a scatter plot. So even if I remember scatter plot, I can use a help and I can directly get. But if I don't know there is a scatter plot, then I'm stuck. Okay, so like that, each and every type of your graph you should remember. Okay, that's the first point. Try to remember that initially. So then again, pandas is very important. So I always give highest percentage of weightage to the pandas itself, because even if I know everything about my machine learning, every algorithm, how to call, if I don't know pandas, it's of no use, because I cannot give it raw data which I collect from some sensors, some points. I cannot give it to a machine learning algorithm. It will just give you 20-30% accuracy. That's of no use to you, right? So in order to build a very good algorithm, data processing munging is very important. So always suggest, start with the pandas, make pandas perfect from your side. So pandas, then the plotting is also equally important. So that normally takes your 20 to 30% of the actual code. You may write 10,000 lines of code roughly, right? If that is the length, roughly 2,000 lines of code will be coming from this part. That's what I'm saying. Okay, then comes to the next part, that actually depends upon what algorithm you are going to use. So regression means what we have done today, right? Starting from the regression part. So you see, all these codes are writing from scratch. Most of the time you will not do these code. So these kind of codings you will not do. I'll now itself I'll make clear? Don't try to remember everything that you see here. What is important? First we did, right? Today's class, very first session. You just try to remember this is important. You may have to see something like this. So what are these types of graphs that is important, right? I'll directly come to what is important. You load the data set directly. If the data is very proper, split it into training and testing. One very important. Once you do that, then you decide which algorithm you want to use. I wanted linear regression that is present inside sklearn linear model. If you choose to use TensorFlow, right, you will go to from TensorFlow dot something something, bring something. That's what you do. So directly bring your particular model. Then these are the lines, common lines you see everywhere. LR is equal to linear regression. If the method is Bayes rule, Navy Bayes, NB is equal to Navy Bayes, but you don't use this, you call it something else. Okay, so from sklearn dot Bayes, bring it something, so something like that will come. So this is the Bayes rule. You apply the Bayes rule as an object, then the fit, right, then the test, and then just calculate the precisions, whatever, right, accuracy, precision, F1 score, many things will come at a later stage. We'll be doing that. So actual implementation of the particular algorithm happens in just 5 to 6 lines of code, starting from here, right? So line number 35 to line number 42 is what is very important. This structure, if you remember, that is enough. But which algorithm you use, that depends upon, right? Once we learn, once we through our this course, maybe in the next session onwards, I'll jump to the next that is logistic regression. Okay, so in that you come to know that, okay, logistic regression means this is the equation. We are fundamentally solving this equation to make the classes out of it. So you will understand. So remember that equation. For that implementing that equation, which particular tool we use, how do you do this and the next lines, etc. Anyway, I'm going to show. So initially, right now, this may looks like, okay, this is something very huge, but actually it's very simple. Don't think that this is difficult, this is complex, nothing. Okay, so as the time progresses, by the end of this machine learning module itself, you will be confident implementing at least 5 to 6 different ML algorithms. I will assure you. Okay, but just stick to what I said. Start from the scratch, learn the Python, NumPy, Pandas, Matplotlib, and Seaborn. They are very important. So remembering that is important. If we don't have that, we cannot implement any of these machine learning algorithms, because data has to be perfect. Data has to be structured. Data should not have missing numbers. No mix up of data types. In the sense, I have a column in the middle, I have a number. Not going to. Machine makes mistakes over there. Machine gets confused. Just like that. Okay. So I hope I try to answer that question. All right. Please go ahead. Any other question? Yeah. Towards the end. Okay. Okay. This part. This is the last one. Okay. So that's how we perform what is called as the gradient descent. Along with this, when you receive this particular code, anyway, I am right now, I'm not having a time to type and do the calculations again. So, but remember, after this particular line number 74, you will get few more lines of code. Okay, run it by yourself. That will be the code for the stochastic gradient descent. This is a batch. You understand batch? Everything given once. Next part of the code will be giving one by one data at a time, and every time you give a data, the machine is learning. Machine updates n value and the c value. Okay, so only that is the difference, right? Just go through that. It's very straightforward. And as I mentioned, this kind of coding you will not do, but just to make sure that you understand the concept behind this. What is the concept behind this? I have written all these codes. Okay, so this is something like writing from very scratch. If you are supposed to write something by yourself without using any of the what you call built-in commands, this is how the code looks like. Okay, again, we took a very simple data, so the code is actually simple here, but definitely on a complex level, it's impossible to write such codes. Okay, but still we try to do this with a simple data set, practical data set, length versus the time square of our the pendulum oscillation, and we try to implement this. So remember, few more lines of code, right? Very similar to this. I will define another function and I will call that function and I'll try to plot something. Okay, so that will be the next part of the code. Remember, line number 74 we have written, we have finished that, right? Line number 75 onwards is what I expect you to run again. Okay, when you get time, run that. And again, that whole concept is called as the stochastic gradient descent, where you give data one by one. I may have so many data points. I'm not passing everything at once. I'm giving one by one. Every time you give a data, machine calculates the error and updates the weight. So that's a fundamental difference. This I want you to know. That's why I am covering now itself. And another part called as mini batch will come in the neural network. Okay, that will be a part that we are going to study at a later stage when we reach the end of machine learning and when we jump into the deep learning. Okay, until then, mini batch, don't worry. Even if you hear that word, don't worry, leave it. Okay, batch, everything at once. And the stochastic gradient descent is one data at a time. Every time you give a data, machine calculates error and updates the parameters, theta in general, or m comma c in this case. And okay, so that brings to the end of today's session. If you have any doubt, please go ahead.